Welcome to clickmyproject.com. Our project title is the Bitonic filter, linear filtering in an edge preserving morphological framework. Abstract: a new filter is presented which has a better edges and detail preserving a properties than the median and the noise reducing a capability similar to a Gaussian, and it's applicable to a many signal to noise types. It is built on the definition of a signal as a Bitonic containing only one local minima or a maxima within the filter range. This definition is based on the data ranking rather than the value. Hence, the Bitonic filter comprising a combination of a nonlinear, morphological and the linear operators. It has a no data level sensitivity parameters and can locally adapt to this signal and the noise level in the image, previously preserving both the smooth and the discontinuity signal of any levels when there is no signal, but also reducing the noises in other areas without creating an additional artifact noise. Both the basic of the performance of the filters are examined in detail, and it is soon to be a significant improvement on the Gaussian and median. It is also compared over the various noisy images to the image guided filter, antistrophic diffusion, non-local means and gain filter, and self-dual form of a leveling and ranking filter. In terms of signal to noise, the Bitonic filter outperforms all these except non-local means and sometimes antistrophic diffusion. However, it gives a good visual results in all circumstances, which characteristics which make it appropriate particularly for a signal or images with varying noises or features at varying levels. Let us see the flow of our project. First one is an image acquisition, that is get an input image. The first stage of any vision system is the image acquisition stage. Image acquisition is the digitalization and storage of an image. After the image has been obtained, various methods of preprocessing can be applied to the image to performing the many different vision tasks required today. The first, capturing the input image from the source file by using the UI get file and ImRead function. User can able to change the size of the input by providing the pixel height and the width with the help of the image resize function. The input images were applied for a linear filtering. We are applying to the Gaussian filter to our input image. The Gaussian filter is often used to removing the noise from the images. Its process is employed to filtering the image in order to removing the unwanted images pixels in the images. Next one is an Bitonic filter. This is a filter for removing the noise in the signals and the images while preserving the edges and other Bitonic data. It's anything with either one local minimum or a maximum within the range of the filter. It has a better edge preserving properties than the median filter, whilst also removing the noise similarity to the Gaussian filter. It has a wide applicable and a very few parameters which no needs for a training or a prior knowledge of the noise variance, and hence the particularly suited a situation where the noise is invariance. Next one is a median filter. The median filter is normally used to reducing the noises in the images somewhat that like a human mean filter. However, it is often does a better job than the mean filter of preserving useful detail in the image. Like the mean filter considering each pixels in turns and look at their neighboring to reducing a whether or not it is a repetition of the surrounds. It's instantly of simple replacing the pixels values with means of a neighboring pixel values. It's replacing with the median of these values. The median value is calculated the first sorting all the pixels values from the surrounding neighborhood into a numerical order, and then replacing the pixels being considered with the middle pixel value. The next one is an OCCO filtering. It particularly the OCCO filters takes the average of an opening then closing and closing then opening, which has an advantages of being a self-real symmetric data values. The morphologically close operation is a dilation of following by an erosion using the sum of structural element in the both operations. The average of the rank based on the opening and the closing with the closing opening, expecting the centile based on the operations CWC, OWC were used within the C fixes and 10% to improving the performance. Next one is a guided filter. This is a novel types of expectatively image filters. In the guide filter, derived from the local linear model, and the guided filter generating the filters output by considering the constant of guidance image, which can be the input images itself or another different images. The guided filter can performing an edge preserving smoothing operation like a popular bilateral filter, but has a better behavior of near edges. Next one is a diffusion filtering. In image processing and we come to and the computational version, the antistrophic diffusion is called an diffusion. Antistrophic diffusion resembles the process of creating the scale space where an image generating a parameter family of a successfully more and more blurred images based on the difference process. Now finally we are calculating the performance measure. The performance measures of enhancement process is measuring based on the PSNR and the FSM calculation. The calculated performance metrics indicates that the proposed method is more effective compared to the existing methods. Now we are going to discuss about the output of our project. First, selected the current folder and selected a main.m file, then right click the main.m file and run the process. Now I selected one images from the dataset folder. Now I selected one.jpg image. Now this is running. First one is an input image. First one is an input image. This is our input image. Then this image is resized on the m cross n values, particular height and width. Then the noise value is added randomly. The noise value is added here. The noise value source if the input image pixels is changed here, then the Gaussian filter is applied. This is an input image, the noise the input image, then the Gaussian filter is applied here. Unwanted pixels are removed. Next one is an Bitonic filtering. Here the input noises is reduced for an Bitonic filtering. Comparing with an Gaussian filter, the Bitonic filter output is an best. Next one is a median filter. The median value is applied here. Here the repeating pixels are ignored. Then the opening closing value is applied. The open filter is applied unto removing the noises, and closing filter is applied here and removing the unwanted pixels in the images. Here the comparison of opening and the closing filter. Next one is a guided filter. Guided filter is applied and the noises is fully removed. Then the light variation in the pixels. Next one is a diffusion filtering. The diffusion filtering is similar on the Bitonic filter and the Gaussian filter is applied. Finally, the performance measure is calculated here. The PSNR of the input noisy image is 32.6101. Then the Gaussian filter PSNR value is 39 and the Bitonic filter is 43.67 and the median filter is 33.15 and opening and closing filter is followed here. Here the 43.61 is a best value. That is our process of a Bitonic filter is a best output. Thank you for listening. Our demo is completed.